Welcome to the first lecture of week 3. In this week, we are going to apply the tools that we learned in the last week regarding consumer decision making to see how consumers choose between consumption today and consumption tomorrow. The consumer in the last week was choosing between commodities or bundles of commodities. Here, we do not have commodities. Instead, we have two choices, or the commodities are replaced by current consumption and future consumption. It turns out all the tools that we learned in the last week can be applied to this intertemporal choice as well. Why do we want to study intertemporal choice? We want to study intertemporal choice because that helps us understand how consumers make consumption and savings decisions. These savings decisions affect the supply of savings in the financial markets and in return affects the price at which this money is going to be borrowed. It turns out that money can be borrowed in a variety of ways. It could be a simple loan taken from the bank. It could be a simple bond which a government issues or a corporate uh, a firm could issue, or it could be a series of uh, convertible bonds or some other financial asset that is used to raise money. Depending upon what rate of return we have on these financial instruments, how much I would save and in what form I would save would depend on that, which means the price of an asset is closely linked to the intertemporal choice uh, mechanism or intertemporal choice process of consumers. So it is important to understand how consumers make intertemporal choice and how we can capture that intertemporal choice with a simple model of consumer decision making. Usually, persons receive income in lump sums or in lumps. Example, monthly salary. Now the question is, how is a lump of income spread over the following month? Saving now for consumption later? Or how is consumption financed by borrowing now against income to be received at the end of the month? These are important questions that we would address in intertemporal choice. In order to figure out uh, how to address these questions with the model of intertemporal choice, we need to learn a few concepts that would come handy in figuring out the role of the financial markets. So, the first concept that we want to look at is the present and future value. So, begin with some simple financial arithmetic. For example, let's just take two periods, 1 and 2. Then let R denote the interest rate per period. Example, if R is equal to zero point 0.1, then $100 saved at the start of the period 1 becomes 110 at the start of the period 2. The value next period of a dollar saved now is the future value of that dollar. So, given an interest rate R, the future value of one period from now of $1 is given to you by 1 plus R. We call it future value. Now, this is true for a dollar. It would be true for any given random amount, which we call M. It could be $100. It could be $200. Future value at the rate of R would be given to you in a two-period model by M into 1 plus R. Exactly opposite of future value is the idea of present value. Suppose you can pay now to obtain a dollar one at the start of the next period. So it's like you are paying for the promise of receiving a dollar one at the start of the next period. For the sake of this lecture, let's assume that there is no uncertainty about receiving that dollar. If you buy the promise, you will definitely get the dollar at the end of the next period. The question is, how much should you pay for such a promise? A dollar one to get dollar at the end of the next period? Of course not. If you are paying dollar one today to get a dollar next period, then uh, it doesn't really make sense because the value of the dollar is going to go down over a period of time. There is also a sacrifice of liquidity that you are making, and therefore you would like to get some return on the sacrifice. Or think of it this way, if you kept your dollar one now and saved it, then at the start of the next period, you would have dollar one plus R, which is greater than dollar one. So paying dollar one now for dollar one next period is a bad deal. You could do better by just depositing that dollar in a bank account and collecting 1 plus R at the end of the one period. So present value basically tells you how much money would you have to be saved now in the present to obtain a dollar at the start of the next period. So for example, if dollar $m saved now becomes dollar $m into 1 plus R at the start of the next period, so we want the value of m for which m into 1 plus r is going to be equal to 1. So that is what I am basically thinking about, right? I am going to receive $1 at the end of the period. There is some amount m that if I put in the bank at the rate of 1 plus r, that would give me $1 at the end of the one period. Then that m is the maximum price that I would like to pay for a promise of receiving a dollar one at the end of the second period. So to figure out m, we will have to divide both the sides of this equation by 1 plus r, which gives us m is equal to 1 divided by 1 plus r. So in order to receive a dollar one at the end of the next at the end of the first period or the start of the next period, the maximum amount that you would like to pay for that is 1 divided by 1 plus r. Now, given that r is going to be positive, obviously this fraction here is going to amount to less than 1, which means to get a dollar at the end of this period or start of the next period, you're not going to pay a dollar today, you're going to pay less than that. The value which you are going to pay for obtaining that a dollar after or the start of the next period is called the present value of the dollar. So the present value of the dollar that you are going to get at the start of the next period is 1 upon 1 plus r. Similarly, the present value of dollar $m available at the start of the next month or the next period is m divided by 1 plus r. How does this look in with examples, with numbers? So for example, let's say that R is 10%. Then the most you should pay now for dollar one available next period is 1 divided by 1 plus zero point 0.1, which is 91 cents. You should not pay, if the rate of interest that you are facing is 10%, then you should not pay anything more than 91 cents today in order to get a dollar one at the start of the next period. What happens if rate of return increases or if the rate of interest is zero point 0.2? Well, the denominator increases in this equation, which means the present value goes down. So at a higher rate of interest, you would be willing to pay lower in order to get that dollar at the start of the next period. Why are we doing all this? At the heart of the intertemporal choice problem uh, is this interplay between current period and future period. You get current income in the current period, you get future income in the future period or the second period. Similarly, you choose to consume something today and you choose to consume, or you are going to consume something tomorrow. Now, how do we compare these amounts? How do we add income that I got today with income that I'm going to receive in period two? Because the choice between C1 and C2 has to be made today, even though I'm going to receive my second period income in the second period, and I'm going to actually consume my second period, whatever bundle that I have decided to consume, actually in the second period. But I have to decide it today, which means that both M2 and C2 cannot be simply represented as M2 and C2 today. We have to calculate the present value of both M2 and C2 in order for them to be meaningful numbers today, so that based on that, we could think about making a choice of consumption today versus tomorrow. All right, let's stop here. Uh, I urge you to take the first quiz and then go on to the second lecture video. Thank you.